CC 615 Cloud Infrastructure class, Week 4, Network, Part 2. Virtual Local Area Network, or VLANs. What is a VLAN? Routers implementing local area networks within a company can be further programmed to split local area networks into logical segments by storing information about the membership of each segment and making sure that they are isolated, which means one can't get from one to another. Such segments are called VLANs, which stands for Virtual Local Area Network. As network hardware can be virtualized in the cloud data centers, creation and control of VLANs can be done in a cloud way, on demand and programmatically. This is called Software-Defined Networking, or SDN, and allows cloud vendors to create separate VLANs for different cloud customers. These VLANs can be also split into subnets if necessary. VLANs can be public, which means they are accessible from public internet, or private, isolated within the provider's private network. To continue with the phone system analogy, the company phone switch software may be able to separate out all HR department internal phone extension numbers and isolate them so that they only talk to each other. If an external or other department extension number wants to talk to HR, they can be rejected or verified and admitted. To ensure privacy and security, cloud vendors deploy customer servers into separate VLANs. Servers deployed to public VLANs have access to internet. Private VLANs allow servers to be isolated from direct public internet access, and customer must define access rules for them. Data center routers route traffic in and out of these VLANs, enforcing these access rules so they are isolated and secured. Public, dynamic, static, private IP addresses in VLANs. When you provision a cloud server, you may request it to be put into a public VLAN, and the cloud vendor assigns a public internet IP address to your server. You may request a dynamic IP address or, for a price, a static one, which means that it will survive virtual server restarts and reallocations. In addition, each server is deployed into a private VLAN. If you don't specify otherwise, the vendor creates a private VLAN for you and assigns a private IP address within that VLAN, which may be again requested as dynamic or static. Servers may use these private IP addresses to communicate with other servers within their private VLANs. Creation of VLANs can be done separately, and customers can create multiple private VLANs to implement security requirements for various servers and deploy servers to these previously created VLANs as needed. Customers may also create subnets within their VLANs and deploy servers to specific subnets. Cloud vendors provide customers with domain name system or DNS services, which allow for the routing of traffic to IP addresses assigned to servers within the cloud VLANs using human-friendly host and domain names. Unfortunately, different vendors use different names for elements of their software-defined networking environment. For more information, see Amazon Web Services Virtual Private Clouds, or VPCs, and Microsoft Azure Virtual Networks. See the enclosed links for more information. Virtual network security and separation. Firewalls. To guard virtual servers and VLANs against intrusion, cloud vendors use firewalls. Firewalls are hardware or software security devices used for monitoring network traffic and allowing or disallowing network communication based on a set of firewall rules. A firewall can guard an individual server as a software firewall installed at the server, or it can be also a separate server running a security software package guarding a whole VLAN. Firewalls as separate servers are often called network appliances, and they can fulfill other goals such as network address translation, or NAT, which allows for hiding internal and private IP addresses. For more information on firewalls and Microsoft Azure network appliances, see the links provided. VPN. To establish a secure connection between external computers or networks and cloud private VLANs, customers can use VPN, or Virtual Private Network connections. VPN software establishes a secure encrypted tunnel for exchanging communication between two VPN endpoints. VPN can also be used for securing traffic between private VLANs. Cloud vendors offer VPN connection endpoints on servers and network appliances using VPN protocols such as Secure Socket Layer SSL based or Internet Protocol Security IPsec based. For more information about VPN, see these links. Network separation and security groups. To comply with security requirements, organizations have to define strict access rules for their servers, both physical and virtual. For example, if a web application uses a server running a publicly accessible web server, and the web server uses a separate database server, the database server in most cases needs to be hidden from the public internet. This can be achieved by provisioning a separate private VLAN for the database server with no public IP address and specifying access rules to make sure that the web server and only that server can access it. To access the database server for database maintenance purposes, clients can use a VPN connection to it. VPNs can also be used to connect between companies' on-premises private networks and private VLANs in the cloud, making these private VLANs in the cloud effective extensions of the company's private networks. Cloud vendors allowed cloud customers to define access rules for both their servers and VLANs. A mechanism called security group allows customers to specify a number of rules for a server or a group of servers, allowing or disallowing communications to or from particular IP addresses, ports, and protocols. These rules are then implemented by the cloud vendors' network appliances. Cloud vendors provide various network access control mechanisms with varying levels of protection, like individual servers, whole VLANs, or subnet within VLANs. They may also be called network access control lists or ACLs or routing tables. For a description of those features in Amazon Web Services, see the link provided. In summary, this week we started with reviewing of networking basics, talking about OSI model, IP addresses, public and private, and CIDR notation. Next, we covered virtual local area networks or VLANs, defining them, and talking about public, dynamic, static, and private IP addresses within VLANs. Finally, we talked about virtual network security and separation, firewalls, VPN, and network separation, including security groups. Thank you.